Welcome back, everyone. I'm Steve,
And I'm Scott
and together we're Backyard Musings, broadcasting live in the backyard,
in the
Apple
back,
Valley.
Apple Valley, and we are still talking science and technology. So,
We're not the experts, we're the
no,
messengers.
absolutely not.
All right, this is interesting. Infrared imaging data from Japan's Himawari 8 and Himawari 9 meteorological satellites have been successfully applied to track changes in the temperature of Venus's cloud tops over time. Led by researchers at the University of Tokyo, the team analyzed satellite images taken between 2015 and 2025 to estimate brightness, temperatures across daily to yearly timescales. This research was presented on June 30th, 2025 in Earth, Planets, and Space. Would you like to know more?
Their findings reveal previously unseen temperature wave structures and highlight how meteorological satellites can offer valuable, sustained observations of Venus's atmosphere, supplementing data from planetary missions and ground based telescopes.
Normally they're focused on the Earth, and then I guess if Venus is on the horizon, they just look up a little bit and collect the data,
Yeah.
The Himawari 8 and 9 satellites launched in 2014 and 2016 were originally designed to monitor Earth's atmosphere using, I'm going to sneeze, multispectral sensors called
Bless you. Bless you.
Advanced Himawari Imagers, AHIs. However, because Venus occasionally appears near the edge of these instruments' field of view, the research team led by visiting scientist Gaku Nishiyama recognized an opportunity to use the AHIs for planetary observation as well.
Tracking how Venus's cloud top temperatures change over time is key to understanding the planet's atmospheric behavior, including thermal tides and large scale wave activity. Gathering long term data for these processes, however, is challenging.
So yesterday we talked about, or this morning, sorry, we talked about the July happenings in the night.
Yeah.
So if you can get a telescope, Venus is the easiest recognizable planet in the sky.
Yeah, it's usually visible. It's like the first planet that's visible.
You could use binoculars, you could get it.
Yeah.
But when you look at it, it's like it's broiling and roiling because the clouds are so turbulent.
Gotcha.
So I would highly recommend. We'll see. Highly recommend getting you just binoculars, just to see. I mean, incredible storms on Venus. It looks like it's roiling and broiling. Okay, is it my turn?
Yours.
As Nishiyama noted, quote, the atmosphere of Venus has been known to exhibit year-scale variations in reflectance and wind speed. However, no planetary mission has succeeded in continuous observation for longer than 10 years due to their mission lifetimes, he added. Ground-based observations can also contribute to long-term monitoring, but their observations generally have limitations due to the Earth's atmosphere and sunlight during the daytime.
So we've talked about the Voyager satellites.
Oh, many
Those
times.
Things have been going.
Like the
50, 60 years. Yeah. But they're way out, so maybe that's the difference.
Interstellar. They're interstellar.
Meteorological satellites offer a promising solution for continuous planetary observation, largely due to their extended operational lifespans. Himawari 8 and 9 are expected to remain active until 2029. These satellites are equipped with advanced Himawari imagers, AHIs, which provide multiband infrared data. This capability, still limited in many planetary missions, is essential for measuring temperature at various atmospheric layers, and the AHIs also offer frequent low noise observations.
Cool. To explore the potential of these satellites in Venus research, the team analyzed temporal changes in the Venusian atmosphere and compared the findings with data from previous missions. Quote, we believe this method will provide precious data for Venus science because there might not be any other spacecraft orbiting around Venus until the next planetary missions around 2030, said Nishiyama.
Let's get them up there.
Yeah.
As a first step, the researchers built a data set by extracting all Venus-related images from the AHI records, ultimately identifying 437 usable observations. By accounting for background noise and the apparent size of Venus in each image, they were able to monitor changes in cloud top temperatures during periods when Venus, Earth, and the satellite aligned in a favorable viewing configuration.
The retrieved temporal variations in brightness temperatures were then analyzed on both year and day scales and compared for all infrared bands to investigate variability of thermal tides and planetary scale waves. Sounds technical, but it roils and broils that atmosphere. Variation in thermal tide amplitude was confirmed from the obtained data set. The results were also confirmed a change in amplitude of planetary waves in the atmosphere with time, appearing to decrease with altitude.
While definitive conclusions on the physics behind the detected variations were challenging due to the limited temporal resolution of the AHI data, variations in the thermal tide amplitude appeared to be possibly linking to decadal variations in the Venus atmosphere structure.
Like every 10 years.
Oh, okay.
In addition to successfully applying the Himawari data to planetary observations, the team was further able to use the data to identify calibration discrepancies in data from previous planetary missions. Nishiyama is already looking at implications of the study beyond Venus's horizon. Quote, I think that our novel approach in this study successfully opened a new avenue for long-term and multi-band monitoring of solar system bodies. So other planets, maybe moons of other planets.
Yeah.
This includes the moon and Mercury, which I also study at present. This is his quote. Their infrared spectra contain various information on physical and compositional properties of their surface, which are hints at how these rocky bodies have evolved until the present.
The prospect of accessing a range of geometric conditions untethered from the limitations of ground-based observations is clearly an exciting one. Quote, we hope this study will enable us to access physical and compositional properties as well as atmospheric dynamics and contribute to further understanding of planetary evolution in general, unquote.
The outlook is promising for future long-term monitoring of planets across the multiple wavelengths. Maybe the multiverse too, who knows. This is cool.
Yeah. No, we like talking about space and
what's out there.
It's fascinating.
I saw this article about they found they describe it as spider webs on Mars. It's not spider webs, so I mean that
like
pattern.
A form?
That pattern, yeah. Obviously left from previous water.
Huh. Yeah, I hadn't heard that.
Yeah.
So
crazy.
the more we hear about that planet, it's just fascinating. So, I don't think it's going to happen in my lifetime, but maybe in your son's lifetime or my grandkids' lifetime, they may get an outpost or at least a landing on there.
Where they get some moon, people. Though. We need an outpost.
Yeah. No, we got to get there.
As a launching base.
Right.
All right, folks. Thanks for joining us. We'll catch you tomorrow.
Take care, everyone. Thank you.